So we're going over absolute value inequalities. So I actually have a video in the class, in the video section on this, but it has math errors. So I thought I should redo these. So that's what we're doing here. So let's review absolute value equations, because there are things that we need to know about equations that sort of transfer over to the absolute value inequalities. So the absolute value makes things positive. What that means is that what's inside, so if you have the absolute value of u equal a number, whatever is inside the absolute values can be positive or negative. It's just going to be positive when it comes out. That's why we have u equals k or u equals negative k, because the inside without the absolute values can either be positive or negative. If you have the absolute value equal to 0, then the inside has to be equal to 0. The absolute value, if it equals a negative, there's no solution because it makes things positive, so it can't equal a negative. And then if you have an absolute value equal another absolute value, you basically ignore one of the absolute values when you solve, and then you kind of set it up like you would do if it was just equal to a number. So those are the 4 basic things that you need to know when you solve absolute value equations. And it's very similar when we look at inequalities. We just have to throw in a couple extra things. So we still are going to form 2 things that we're solving, but it's either going to be 2 separate inequalities or it's going to be a compound inequality. But you still have 2 sides. You still have a positive and a negative version. And which one you use depends on if it's a greater than or a less than. So if it's greater than, you're going to get 2 inequalities separated by an or. And when you have the negative, you flip the direction of the inequality. So if u is less than negative, whatever the number is, or u is greater than whatever you have. And your solution is going to be in the form where you're going to have negative infinity to some number, so there would be some number right there, union, and then you would have the other number to positive infinity, because you're going to have a less than part and then a greater than part, and there's not going to be overlap. If your absolute value inequality is a less than when it begins, then this gives us a compound inequality where it's going to be in the middle, and then you're going to have the positive and the negative version on either side, and that's going to be in the form where you're in between these 2 numbers, and that's what your solution is going to be. Your solution is going to be in between. If you have a less than or equal to or greater than equal to, it follows the same rules as the less than and the greater than. You just have to change the symbol, and then your parentheses turn into brackets when you're at the numbers, because now it's a equal to part. So that's how these are similar to this first one right here, where you set up 2 things. It's just now instead of an equal sign, it's going to be different symbols, but it's still kind of an or you have the one where it's combined. So let's look at our situations where we have it equal to 0 and or if it's equal to a negative, but it's not going to be equal. It's going to be like less than. So these are the special cases. So you had different ways, different possible combinations, basically. So instead of equals 0, when it's an inequality, you can have less than 0, greater than 0, less or equal to 0, greater than or equal to 0. If it's less than 0, there's no solution, because it always gives you a positive, and positive numbers are not less than 0. So that's an impossible situation. If it's less than or equal to 0, it can't be less than 0, so it has to be equal to 0. So that gets turned into an equal when you start solving. If it's greater than or equal to 0, you have infinite solutions, because the absolute value will always be greater than or equal to 0, because that's just, it's going to be positive or 0, so that's always going to be true. And then if it's greater than 0, you're basically kind of solving, and you just have to make sure that you don't include 0. So it's like you're solving u not equal to 0, because it's like everything but 0. 0 can't be included there. So you're going to have all real numbers, except there's going to be some number that's not allowed, and that's going to be wherever that is equal to 0. So that is how we deal with the 0 parts. So now let's look at how we deal with negatives if the absolute value has a negative outside of the absolute value when it's being compared to a negative. So if you have a less than negative, there's no solution, because it's never going to be smaller than a negative, because you're always getting positives. If you have a less than or equal to a negative, it's still going to be no solution, because it can't be equal to a negative, and it's certainly not going to be less than a negative, because it's always positive. If it's greater than a negative, you actually have infinite solutions, because it's always going to be greater than a negative number, because it gives you positives. If it's greater than or equal to negative, again, you're also still going to have infinite solutions, because again, it's always going to be greater than, it's always going to be true that it will be greater than or equal to a negative. So those negatives are not as complicated as the zeros. If it's less than a negative, no solution. If it's greater than, infinite solutions. So when you're solving these, I recommend having these charts handy, you know, putting these in your notes, something that you can refer to, maybe putting these on note cards, so that way you look at the form of your equation and then you can decide how are you solving it, and then is it one of the special cases. So steps for solving an absolute value inequality. First, you need to use any addition and subtraction properties, because you need to get the absolute value by itself, and it has to be on the left. So when you have absolute value equations, it doesn't matter if the absolute value is on the left or the right. But when we have things with inequalities, our variable always has to be on the left of the inequality. So you have to make sure your absolute value is always on the left side. So if it's not, you have to put it on the left side, and you have to make sure that any number that you have that's added or subtracted is on the other side. Step 2 is you need to use the multiplication or division property if you have a number in front of your absolute value. So if you had something like 2 times the absolute value of x minus 5, you would have to divide both sides by 2 to get rid of that number in front. And if it's a negative, you have to remember that the inequality changes direction. It gets reversed. Because whenever we multiply or divide by a negative, the inequality changes direction. So once you've got the absolute value by itself, which you should have after these first 2 steps, then you need to turn your absolute value inequality into the linear inequality or equation following these steps here. Basically, you're either going to write it in one of these 2, or if it's a special case, you're going to be looking at your special cases, but you're going to be writing it so it's no longer in the absolute value form. So that's key right here. No longer absolute value form. You're doing this step to get rid of the absolute value form. Then you're going to have something that you can solve, and it's going to be a linear inequality unless it's one of the special cases. And so you solve using the things from linear inequalities, which we talked about in week 1. And then you're going to have to give your answer an interval notation, because it's not, unlike the absolute value equations where you get 2 answers, you're going to have a range of values that work because it's an inequality. So you want to give it an interval notation, and sometimes it helps to graph it, or you can follow the rules here, because this will basically tell you what the form is that it's going to be in. And then if it's not in that form, again, you can kind of figure out, is it going to be no solution, infinite solutions, that sort of thing. So those are the steps. That's very similar to when we're solving any type of equation. We just have to look at the direction of the inequality symbol because that will determine how we write the form when we remove the absolute values. And we have to think about negatives and zeros and what that means for the solution. So we're just going to go with lots of examples here so that you can get lots of practice. So first one on the left, we have the absolute value of x minus 7 less than 5. So this is not one of the special cases. The special cases are when you've got 0 or a negative involved. So this is not a special case. The less than always gets written as a compound inequality. So we're in the second form right here, the absolute value of u less than a number. So we're going to be writing it in a compound inequality, and then our answer is going to be between whatever our two numbers are. So we don't have to do any manipulating. We already have the absolute value by itself. So I'm going to have whatever's inside the absolute value. We're removing the absolute value in this step, and it's going to be less than 5. So first, it's going to look exactly the same like it did. But then on the other end, you're going to have negative 5. And that's how we're going to get it to a compound inequality. So we do this because it's the less than. So the less than is always going to be in this form. Then we are now solving a compound inequality. So now this is something that you've seen before. And we need to get x by itself. So we're going to add the 7. And you have to do it to 3 pieces here instead of just 2. So you've got 3 parts that you're looking at. And so this gives us 2 is less than x, which is less than 12. And so that's our solution, but we want to write our solution in interval notation. So when you've got a compound inequality like this, it's basically just like how it's written. You don't need the variable. It's going to be written with a parenthesis because it's a less than. Then our lowest number is 2, our largest number is 12, and then we close the parenthesis because it's a less than. So that is the interval notation, and that is the solution. And if you were to graph this, we're going to have 2 and 12 on our number line. And our solution is just in between these, but we're not including the endpoints. Because we're less than, we can't be equal to them. We're not allowed to include those endpoints. So that's the left one. Now on the right, we've got the absolute value of 9 minus 2x less than or equal to 0. This is one of the special cases because it's got this 0. A less than or equal to 0 gets turned into an equal 0 when you're solving. Because we can't be less than 0. It's impossible. So we can only be equal to 0. So when you're solving this, you're really solving 9 minus 2x. The absolute values is equal to 0. And there is no plus or minus 0. There's no sign for 0. So it's really just 9x or 9 minus 2x equals 0. So when we solve this, we are adding 2x to both sides. I could subtract 9 from both sides, but this is just avoids negatives when I do it this way. So I have 9 equals 2x. And then I divide by 2. And we get 9 halves equals x. So in this case, our solution is not an interval notation because it's a single number. And so we put it in curly braces to indicate that we just have one number for our solution. And when you graph this, all you have is basically a dot at that one number as your solution. And then nothing else is going to work. If we try to plug in a number smaller than 9/2, so 9/2 is 4.5. So if I wanted to put a number in the absolute value that's like 4 to the left of 9/2, it's not going to work. And I'm going to just pull up a calculator so we can just do this. Okay. So we have this equation. The left side is the absolute value. We've got 9 minus 2x. So let's say instead of, we know that 9/2 works, which is 4.5. So if I tried 4, that gives me an answer of 1. So 1 is not less than or equal to 0, because that's what our original problem was. It's not equal to 0, it's not less than or equal to 0. So a number on the left doesn't work. A number on the right would be like 5. So if I plugged in 5 for x, again, we're getting 1. It's not going to work. It's not less than or equal to 0. And you can keep trying different numbers here. And the larger the number you put in here, it's just going to get bigger here. And if I put in even like a negative number, it's still not going to get me close to 0. The only place where I'm going to be less than or equal to 0 is at 9/2. And so you can just play around, plug in numbers, even if I get really close and I did 4.4, that gets me close to 0, but I'm not going to be at 0. The only place is 9/2, and it's impossible for me to be less than 0 because this absolute value will always become positive. Are there any questions on either of these two examples? Okay, so let's move on. On the left, we have 2 times the absolute value of 1 minus 2x, then less than or equal to negative 10. Now, you don't want to see that negative 10 and say, oh, automatically this is not going to work. You need to get the absolute value by itself first, because sometimes if you had a negative in front of the absolute value and you divide, it may become positive. So you can't just at this stage decide it's got a negative there is no solution. You have to get the absolute value by itself first. So to do that, we have to divide both sides by 2. And that will get rid of the 2 that's in front of the absolute value. So 1 minus 2x less than or equal to, and we're not flipping because we're only dividing by a positive. And then negative 10 divided by 2 is negative 5. And now we've got the absolute value less than or equal to a negative, and this is one of our special cases. Because this is impossible. No matter what number I plug in, that absolute value is going to come out positive. I'm never going to get something that's less than negative 5, and I'm never going to get something that's equal to negative 5. So this is one where we have no solution. So when we write it, we usually use this symbol right here to mean an empty set. Or sometimes you'll just use the set symbols with nothing in it. And then when you graph it, all you have is an empty graph. There's nothing on the graph. It's just empty. There's no dots, there's nothing. It's just a number line with nothing on it. So this is one of the special cases because you've got a negative there. Now on the right, We have the absolute value by itself, but it's greater than -6. This is another special case, but this is one where we have infinite solutions because it will always be greater than -6. So it's sort of the opposite of the one on the left. So this is another special case where we have infinite solutions. So when we write our solution, we're going to use interval notation, and we write from -infinity to +infinity. And when you have the number line, the whole thing is colored in. So it's like the complete opposite of the example to the left. So recognizing the special cases is nice because you don't have to actually go and do any solving because you know the solution already. Now let's say you didn't notice this because sometimes you don't notice and you just go and you just start solving. You can still recover and you can still get the same solutions even if you didn't notice. So I'm actually going to put in a blank slide and I'm going to work those out. So let's say we didn't notice on the left that it was no solution. And we divided both sides by 2 and we had the absolute value of 1 minus 2x less than or equal to -5. So if you don't notice, you've got the less than or equal to, and that's where you get the compound inequality. So you first write it without the absolute value symbols, and then you write it with the other side. But now you have the opposite of -5, so that becomes a +5. So this is what we've got so far, because we just changed the sign when you have it on the left side. Now, if you look at this, this is kind of, it looks impossible. I'm somehow less than -5, but also greater than 5. But we're going to go and solve. So first I need to subtract 1. So I have to do that from three portions. I got 4 is less than or equal to -2x less than or equal to -6. Then we're going to divide everything by -2. And when we do that, the inequalities have to change direction because we're dividing by negative. So I just circle them to remind myself. And then we get -2 is now greater than or equal to x greater than or equal to 3. So let's look at what this means. If you look at just the left part, ignore the right. So if we look at just this part, we're saying -2 is greater than or equal to x, or x is less than or equal to -2. So we're saying x is somewhere over here. Now this is an and. When you're doing a compound inequality, it has to be true in both areas. So the other side is saying x is greater than 3. So we're kind of over here. Actually, I should put that above because that's not our solution. This is an and. It's supposed to be true at both of these at the same time. But we can't be in both of these sections at the same time because they don't even overlap. The and is looking for the overlap, and there's no overlap here. So this is how you can determine that there's no solution, even if you didn't notice right away that it was one of the special cases. You can still solve, and then when you're trying to determine your solution, you're going to get something that contradicts itself. It's not going to make sense. X can't be smaller than -2 and bigger than 3 at the same time. There's not one number that does that. So there's no solution there. Now the other one, the other special case here, if you didn't notice that you had a special case on the right where it's the absolute value of x over 2 greater than -6. So let's say you were solving that and you didn't notice. Just separate that. A greater than goes into two separate inequalities. One that looks just like it was without the absolute values. Then you have an or, so it's one or the other. And then you change the direction of the inequality and you change the number. So it becomes a less than 6. So when we solve, I'm multiplying both sides by 2. And I'm doing that for both of these. So I get x is greater than -12 or x is less than 12. Now the or means you're looking for anything that works. So in week 1, we were really hitting this is one of the things that you guys had to do with the, how to graph these because it's really important this week. So the greater than -12 would look like this, or greater than -12. The less than 12 look like this. And the or means whatever you see graphed is part of your answer. So we end up having the whole number line graphed. And that's what gets us infinite solutions here, because the whole number line gets covered between these two inequalities. So if you didn't notice this was a special case, you can still solve and get the same answer. But I do recommend keeping those special cases handy because it saves you work. Because then you don't have to go and solve, you just recognize, oh, this is one of the special cases, so I don't have to do anything, I already know the solution. Are there any questions on either of these two examples, either the special case form or when I actually worked it out to get to the same answer? All right. So here we go. We've got more. So on the left, the absolute value of 4x plus 5. Then we have plus 7, and then less than 7. So first I have to get the absolute value by itself. So I need to subtract 7 from both sides. So this gives me the absolute value of 4x plus 5 is less than 0. So we've got 0, we've got the absolute value, and then we've got a 0. So we have to go back to our special cases. If it's less than 0, there's no solution because we can't be less than 0. It's just never going to happen. So as soon as you get to that, you recognize we've got a special case. And so our solution is no solution. We've basically got the empty set. And I'm not going to bother graphing it because it's just an empty graph. The one on the right, once again, we've got a special case because we've got 0. So before I go and go back to the sheet with special cases, just think it through. We've got the absolute value greater than 0 or equal to 0. What do you think the answer is? You can go ahead and type it in the chat. Do you think there's going to be no solution? Do you think there's going to be infinite solutions? Or do you think there's going to be one solution? All right, we've got 2 votes for infinite solutions. And that's correct, because no matter what I put inside the absolute value, it's always going to be greater than or equal to 0. It could be equal to 0 or it could be bigger. It's always going to be true. So this is going to be all real numbers. So it's negative infinity to positive infinity when you write your solution. And again, I'm just not going to bother to graph this one. So if you can't like logically work this out, and this is actually one of the benefits to why you learn these absolute value inequalities, is it really, you can, you know, when you have these special cases, you can kind of logic your way through. But if you're, you know, not very good at that, you've got this chart that you can print out tomorrow when I email this out, and then you've got, you know, notes right there that you can refer to. Okay, now let's look at these two. We've got on the left the absolute value k minus 7 less than -3. So what do you think? Do we have no solution? Do we have infinite solutions, or do we have a one solution situation? We've got this negative, so we know it's going to be one of the special cases. So which one do you think it is? No solution. And that's correct, because we can't have an absolute value less than a negative. So again, another one where it's going to be no solution. Now, how about on the right? Now, this one's a little tricky because it's in the opposite order that we would normally look at it. We've got the absolute value part on the right rather than the left, but we've got -5 less than or equal to the absolute value of 2x minus 1. Do you think that we're going to have, this is another special case because we've got this absolute value. Do you think we're going to have no solution, infinite solutions, or one solution? If you're struggling to think about this one, you can rearrange it. You can basically, when you rearrange it, you take the mirror image so that the inequality has to change directions, because you still need to have the open part facing the same direction and the pointy part still in the same part. So we've got to vote for infinite. We've got the absolute value, when you rewrite it this way, we've got the absolute value greater than or equal to negative, which is always true because it's going to be positive. So that's always greater than a negative number. So this is another infinite solution. So you've got negative infinity to positive infinity. Are there any questions so far? Okay, go ahead, ask your question. On number 2, why is it no solution? The first one, this one, or the one we just did here? Or are you talking about a different one that we did no solution? This one here. 9 minus 2. Okay. Nine minus 2. Sorry, I'm not following. Oh, okay. So this one is, oh, why was it not a no solution? Okay. It is not a no solution because it is possible to be equal to 0 if you put in 9/2. So there is one solution only. So if I go back to the calculator here, I still have this one up. If I put 9/2 in, we do get 0. And so our inequality is we've got this absolute value less than or equal to 0. So it can't be less than to 0, but it can be equal to 0. And it's equal to 0 when we put in 9/2. So that's why it's not a no solution. There is one solution there, and it's only when it's equal to 0. So that's why we took this less than or equal to and we turned it into an equal to 0, because that's the only way it would work. Because you can put in a number, take the absolute value, and get 0 out. Does that help? Okay. There are other questions? Yes, go ahead, Daniel.
Yes, can you hear me?
Yes, I can.
Awesome. If you can go back to the last question with the infinite solutions that we were just on. That one. So we can change the order and put the -5 to the right side and change the sign, but you don't necessarily change the minus sign. You wouldn't change it to a positive, because that's a little confusing, because when we do it in other problems, you would add.
Here, I'll work. So I did a shortcut. I will show you the full steps that you would do to get to there, because that is basically the shortcut that you just reverse it. If we want the absolute value, I'm going to just rewrite it right here. So if we want the absolute value on the left and the number on the right, so first I would move the number by adding 5 to the right. And then that gives me 0 is less than or equal to the absolute value of 2x minus 1 plus 5. Then I need to move the absolute value to the left. So I need to subtract it. And then that gives me a negative absolute value of 2x minus 1 less than or equal to 5. But we want a positive in front of there. So I need to divide everything by -1, and that changes the direction of the inequality. So when we do that, then we end up with the absolute value of 2x minus 1. And now it's a greater than or equal to -5, which is what I had written, basically the mirror image. So we are following the rules where you're basically, first we had to make the 5 positive to put it on the right. Then the absolute value moved to the left, which then made it negative. But then we had to get rid of that negative. And when you do that, the inequality changes direction. And so that's how we ended up with what we did. So it's just, instead of showing all of that work, it's a lot easier to just know that if you've got an inequality and you want to flip it, if your variable's on the wrong side, just literally flip the sides and change the direction of the inequality. It will work every time.
Yeah, I like that rule better. Thank you.
Yeah, showing the steps is like, you can see what's going on, but it's a lot more work. So just remember the rule. There are other questions on these problems. Okay, so I did a lot with special cases, so let's do some non-special cases. I really wanted to hit on the special cases because that's really where you're getting your critical thinking. But of course, you're going to most of the time not have a special case, so we do need to practice all of the steps. So we've got here the absolute value of x minus 8 minus 2 less than or equal to 14. So the first step is we have to move that minus 2. So we're going to add 2 to both sides. This gives us the absolute value of x minus 8 less than or equal to 16. And whenever you've got a less than, that's always going to be the compound inequality. Whether it's less than or equal to or less than, that's always going to be where it's in between. So we're going to write it in between negative 16 and positive 16. So I add 8 to both sides, or all three sides, because we want to get x by itself. And we get negative 8 is less than or equal to x, which is less than or equal to 24. And so now we're saying that x is between negative 8 and 24, which makes sense. That is something that can happen. And so I'm just going to graph it first versus getting my inequality first. We're just saying that our answer is in between negative 8 and 24, but we're allowed to equal the endpoints, so those are brackets. And so your solution is going to be brackets at these values, negative 8 to 24, instead of parentheses. And it's brackets because of the less than or equal to sign. So the difference between the less than and the less than or equal to is the difference between parentheses and brackets. But whenever you're solving a problem like this, your first step should always be to check if it's a special case, because that saves you time. If it's not a special case, then go through the solving process, and then when it's a compound inequality like this, it's always going to be in between the two numbers, and you just have to determine whether it's brackets or parentheses that comes from the symbol, whether it's a less than or a less than or equal to. Are there any questions on this example? Okay, so here's another one. We've got 2 times the absolute value of x plus 14 plus 3 greater than 17. So I have to do my addition and subtraction. I have to move the 3 before I deal with the 2 in front of the absolute values. So we are going to subtract 3 from both sides. So I have 2 times the absolute value of x plus 14 greater than 14. Now I need to divide both sides by 2 because I've got that 2 in front of the absolute value. So that gives us the absolute value of x plus 14 is greater than 7. Now, greater than is always going to be 2 separate inequalities separated by an or. So we're going to have x plus, oh wait, I want to do this in white, not yellow. We have the x plus 14 greater than 7, exactly as you see it without the symbols. Or then you have the x plus 14 less than negative 7. And we change the inequality because we've got that negative 7 there. So we're going to subtract 14 to solve, and we solve these identically. So I just always do them at the same time. We get x is greater than -7, or x is less than -21. So when you graph these, the or means whatever we've got solutions for, that's what we've got. So I've got to put my -21 and my -7, and we've got that x is greater than -7, so a greater has a parenthesis, and it's bigger, so it's going to the right, or it's less than -21, so that goes to the left. The or means we don't have to have overlap. The and is overlap, the or is not. So we've got two separate sections where we could have solutions. And so when we put these in our interval notation, we need to have parentheses. So first we're always going to go to -infinity to +infinity there. So if I read it from left to right, I start at -infinity, which always has parentheses, and then I'm shading until I hit -21, which has a parenthesis. Then I have a gap. So when you have a gap, you need to use the union symbol to join it to the next part. So then the next part starts at -7 with the parenthesis, and I stop shading when I hit infinity, and infinity always has a parenthesis. So you're taking your two numbers and you're sticking them in this formula where I put the highlights here for our form where we have greater than. Your solution's in the form -infinity to some number union a different number to infinity. So you're just plugging in your numbers, and you need to make sure you put them in the right spot. We always have them go from the smallest to the largest. So this -21 had to be on the left versus the right side because that's smaller than -7. So a very common error I see people do is they put the numbers in the wrong spots. They might get the right number, but they don't have them in the right spot. So graphing can help you make sure you put them in the right locations. And if you remind yourself as we go from left to right, we have to go from smallest to largest, because that's just how we read these number lines. And it's the same thing with the interval notation. It always goes from smallest to largest as you move from left to right. Are there any questions on this example? Okay, here we go with another one. We've got -2, and then absolute value of x plus 1, less than or equal to 16. So I need to divide both sides by -2, because I need to get rid of that negative. And because I'm dividing by negative, I have to change the direction of the inequality. So this is going to give us the absolute value of x plus 1. Now it's going to be a greater than or equal to symbol, and then we end up with -8. So don't get too comfortable with just going through the steps of solving, because if you stop right here, you notice this is one of our special cases. We're greater than or equal to a negative, and that means we have infinite solutions. So sometimes people will start solving, and they start solving a whole bunch of types of problems. You know, you do this one, you do this one, and they just get into a habit and they just keep going. But you want to always think about look for if you have it with a negative or a 0, because that's indicating special case. And in this case, if it's greater than or equal to a negative, it's always going to be infinite solutions. So you don't have to keep going. So don't get into that habit. You can save yourself some time. So I've got one more that I want to make sure that we go through. Negative 11 less than or equal to negative 11 minus absolute value of 2p plus 4. So if we want to have the absolute value on the left side versus the right side, all we need to do is change directions of stuff, and then we change the inequality. So we would have, it would still be negative 11 minus the absolute value 2p plus 4, but the inequality symbol changes direction, but everything else stays the same. So we end up with negative 11 minus absolute value 2p plus 4 greater than or equal to negative 11 if we want to have that absolute value on the left instead of the right. We just had to switch this. So you don't have to do it, you can do it in your first step. You don't have to get the absolute value by itself and then change it. So you can do it right away, and it's just literally you're just flip-flopping, and then the inequality changes direction. So even if there's more than one thing added, it's okay. So once we've got our absolute value on the side that we want to have our absolute value, we're going to add 11 to both sides. So this gives us negative absolute value of 2p plus 4 greater than or equal to 0. Now, we've got this 0, which means we're going to have a special case, but we have to make sure we have a positive absolute value. We don't want to have that negative in front of there. We have to get rid of that first because that does change your answer. So that's basically a negative 1 in front of the absolute value, so we need to divide both sides by negative 1, and that changes the direction of the inequality symbol. So that gives us the absolute value of 2p plus 4, so we don't have that negative anymore, but now it's a less than or equal to 0, because 0 divided by anything is 0. So we can't be less than 0, we can be equal to 0. This is one of the special cases where you solve, where you just set it equal to 0. This is actually just like the one that Jeff asked about right here, where we had the less than or equal to 0. This is the one where you're going to have one solution. Oops, wrong one. Nope, wrong one. Like here we go. So this is the one where you have one solution. So we're just now solving for p. So I'm going to subtract 4 from both sides. And this gives me 2p is equal to negative 4. Then you divide both sides by 2. And we get p is equal to negative 2. So we get one answer, just negative 2. This is one of those special cases where if you tried any other number, it wouldn't work. Only negative 2 works because we had that less than or equal to 0. Are there any questions? Okay, so I realize we never did an example of this last one right here. If you did have an example of this, you would end up with, you know, you need to solve whatever u is not equal to some, whatever the thing, it can't be equal to 0. When you write your solution to this, it's going to look very similar to the greater than, except whatever number you have in these two spots is going to be the same number. And that's going to be the only difference. So it's going to look similar to here with a greater than a number. It's just instead of two different numbers, it's going to be one number, because you can't have whatever number makes it 0, but everything else will work. So I didn't do an example like that. Unfortunately, I should have planned to do one, but that's how that would look if you're putting that interval notation. You would just have one number that's not allowed. Everything else works. So that's all I've got. So thank you guys for attending, participating, asking questions. I appreciate the flexibility. This fall weather, I don't know if you guys get migraines, but the fall weather really messes with my head. It's just something about the change in temperature that just messes with me. But I really appreciate that you guys were able to make it tonight, that you guys were flexible. So if you have any questions on anything else, other topics, feel free to email me. Otherwise, I will see you guys in our next live. So take care.